Welcome and thank you for joining. We'll continue with another thinking question. This time we have the limit as x approaches 2 over rational function. So you have a quadratic over a quadratic here. And we're told that the limit exists and we are about to find the coefficient a. As you can see here, we have a literal coefficient a, which is unknown. Now, the fact that the limit at x equals 2 exists, it means that if you substitute x by 2, we'll be able to estimate the value of this function. So I'm going to start by direct substitution to check first the denominator. So the denominator at x equals 2 will have a value of 2 squared plus 2 minus 6. As you can see in here, the denominator will become 4 plus 2 minus 6, 0. So what that means is that at x equals 2, denominator would be equal to 0. So two things that we are deducing from here. Number one is that the limit is indeterminate. And number two, we're going to say that x minus 2 is a factor in the denominator. So next thing that we have to think of is, well, but the limit exists. So what that means is that x minus 2, which is a factor in the denominator, and is the one that made the denominator equal to 0, the factor that made the denominator equal to 0, must have been somehow simplified in order for the limit to exist. So to be able to estimate the limit, it means that x minus 2 must have been simplified for the denominator. So I'm going to rewrite the expression one more time here, or the limit one more time. So what that means is that denominator now will have x minus 2 as a factor. And obviously the other factor will be x plus 3. So x minus 2 is a factor again because we deduced this from the fact that at x equals 2 the entire expression here became 0. So that would be the factor form. Now since x minus 2 is a factor in the denominator, but the limit exists, it means that x minus 2 must have been simplified by a factor of x minus 2 from the numerator. So we're going to say that since the limit exists at x equals 2 exists, then x minus 2 must have been a factor in the numerator. So what that means again, based on the remainder and factor theorem, is that the value of the numerator at x equals 2 must be equal to 0. So let's make this happen. So we have 2 squared plus a times 2 plus a plus 3 equals 0. Let's simplify. So we have 12 plus 2a plus 1a plus 3 equals 0. So that is 3a plus 15 equals 0, which makes 3a equal to negative 15. So that will make a equal to negative 5. So what we're going to do is substitute a into the equation. So we'll have the limit as x approaches 2 of 3x squared plus ax plus a plus 3. We have the a value of negative 5. So we will substitute a by negative 5. And let's simplify and see what we get from here. So we have the limit as x approaches 2. We'll simplify the numerator, which is now 3x squared minus 5x minus 2, and denominator is x squared plus x minus 6. Let's see if we actually made the limit estimatable. So obviously we have to factor because we need to remove the restriction of 2 from the denominator. And we know that x minus 2 is a factor to both numerator and denominator, which will make it easier for us to factor each of them. So if x minus 2 is a factor in the numerator, that means that the other factor will have the first term 3x to produce a 3x squared, and the other one has to be positive 1 because negative 2 times positive 1 will give the last constant term here. Then the denominator will be again found the other factor, x plus 3. And as you can see, we can now simplify the common factors, and this would be the limit as x approaches 2 of 3x plus 1 over x plus 3. And by direct substitution, we find that this would be 3 times 2 plus 1 divided by 2 plus 3. So that's 6 plus 1, that's a 7 over 5, and that would be the value of the limit. And the limit exists, and the value of a would have been equal to -5. So a equals -5 will make this limit exist, and the limit will have a value of 7 over 5. So I hope this made sense, and thank you for watching. Have a wonderful day. Bye for now.